All right. Hello, everybody. Um, Happy first day of classes. I hope the day is going well for everybody. So the purpose of this video you're about to watch is to help introduce you to some of the concepts that will be covered in your first review assignment over sections 1.1 and 1.2 of our textbook. These are primarily concepts from Pre-Calculus I. So from wherever you took that, whether that was at Pierce or somewhere else. Just review some of these concepts in order to help us get ready for the rest of what we'll be doing in calculus. Now, I'll tell you right now, the amount of material I have to cover on this PowerPoint that you are seeing is quite a bit, and so I'm going to do it over 2 different videos. So this first one will be released today, and then I'll release another one tomorrow. As well, for if you're looking for a copy of the PowerPoint, if you go on our class WAMAP page and open up the block that says in-class PowerPoints, and then look at the one for pre-calculus, or for chapter 1, you will find a copy of this PowerPoint. Now, the other thing I was going to say, for those of you that have had me in class before, you know that I like to start each class with a meme. So you'll see this one here today. I like to start a little class with a little bit of a chuckle every day. All right, so let's jump into our material to cover then. So the first thing we need to talk about are some basic ideas about functions. So here's some important questions we want to ask ourselves. So what is a function? How do we know if a graph represents a function? What does the terms input, output, independent, and dependent mean? How do we know if a function is decreasing, concave up or concave down? And what makes a function even or odd? Now, these are all topics that were covered in Pre-Calculus I, and so I'm actually not going to go over them at length right now. We'll talk about a few of them on the next couple of slides. But if any of these terms look unfamiliar, if you're not remembering some of the definitions for them or what they mean, I would highly suggest either looking back at your notes from wherever you took Pre-Calculus I, or on our class WAMAP page, if you open up the block that says syllabus and textbook, underneath there you'll find a link to the pre-calculus book that we use here at Pierce College, Fort Steilacoom, and that would be a great place to look up some of the answers for some of these things. Okay, so go ahead and when you have the chance, investigate those yourself if you don't remember all of them. All right, so now I want to look at a particular function here and some different characteristics of this function. So over here on the right side of the screen, you'll see a graph of a function, and one of the questions that was on the last slide is how do we tell if a graph represents a function? So I'll let you guys investigate how we know that this graph is in fact a function. And the first question we're asked up there is, what are the domain and range of this function? Okay, so we have to identify what those are in this case. Now you may recall that domain of a function is the set of all possible inputs for the function. The domain's values are given along the horizontal axis. So basically we want to look at, for this function, what values along that horizontal axis is it covering. And note, we're also asked to give our answer in interval form, so we need to keep that in mind as we're going through this. So for the domain, I'm going to put a D here to represent the domain. Okay, and those 2 squiggles are supposed to be colons. I'm sorry, I'm learning how to use my stylus still. So I'm going to look along the horizontal axis. The 2 values are the starting and ending value that the graph is covering. So notice that the leftmost point on the graph corresponds to -1. The rightmost corresponds to 2. So I know the domain of this function is going to go between -1 and 2. And I do that as -1, comma 2. Okay. And then because we're doing this in interval notation, we have to look at brackets and parentheses. And the way we determine that is whether or not the number is included or not included in the domain or the range. So for -1, we notice that here on the graph there is a closed dot. So therefore that is included in the domain. So we know the domain here is going to have a bracket on the -1. And then at 2, we notice there's an open dot, which means that the value gets really, or the graph gets really, really close to that value, but never crosses through it. So we're going to put a parenthesis on that. So our domain here would be bracket -1, comma 2 parenthesis. Okay. So that's domain. Now for range, if you recall, range is the set of output values of a function. So these are going to be now along the vertical axis, and we're looking at the outputs. Okay, so that's where the range goes. So we want to see what values the graph covers along there. Okay, and let me just put an R here for range. Maybe I can put an R. There we go. Okay, so looking at the graph, we notice that the lowest value it covers on the vertical axis is down here. The highest value it seems to cover is over here at 12. And this one that I circled down at the bottom is at 0. So we see the range goes between 0, comma 12. Notice at 0, the graph passes through that point, which means that it's included. So we'll put a bracket there. And then for 12, we notice that there's a dot over here on the graph, that open dot again, which means it gets really, really close to that value, but doesn't go through it. So we're going to put a parenthesis there. So our range would be bracket 0, comma 12 parenthesis. Okay, so that'd be our domain and range in interval notation. All right, let's look now at these terms independent and dependent variables. So you notice these were terms that appeared on the last slide. Okay, and you also notice that on that question on the last slide, they were paired with the terms input and output. So independent and dependent have to do with inputs and outputs, and in fact, they sort of have to do with our domain and range as well. So our independent variables, those will be our inputs. So those are the things that appear along the horizontal axis. And we notice that the variables here, the values along the horizontal axis are represented as x's. So we know that our independent variable here is x. And then the dependent variables, those will be the ones along the vertical axis, so along here now. And we notice that those are y's. So our dependent variable is y. Okay. Now, for those of you that have had me prior to this quarter, you know that I'm a huge stickler on not using only x and y as our only possible variables. We can see things like t's and v's and thetas and gammas and all sorts of different things. And in fact, for those of you continuing on to Calc 2, you'll even see some functions where y is the independent variable and x is the dependent variable. Okay, so that's why it's always important to identify which is which to help you understand where your inputs and your outputs go. Okay, so those would be our independent and dependent variables. Next thing we're asked to look at is value intervals over which the function is increasing and decreasing. Okay, and if you'll recall, when we talk about increasing versus decreasing in a function, there's two ways to think about this. The first is for increasing is where the rate of change is positive, and decreasing is where the rate of change is negative. Or looking at a graph of a function like we have today, or have here, an increasing part of the function would be where the function is going up from left to right, and decreasing would be where it's going down from left to right. So let's first look for increasing. And I noticed that the graph seems to go up from left to right, starting kind of down here at the origin. And then on all of this piece up here, it goes up. Okay, so I identify where it's increasing. And when we do this, we identify it as an interval based on the input values. Okay. So I see here that the input values, it starts at down here, seems to be at 0. And it goes over here to 2. So we have 0, 2. And then at the point 0, you'll notice it's actually right in between, or it's at a lowest point on the graph. So the graph is neither increasing or decreasing there. So we put a parenthesis around that point. And then we notice that the graph gets really, really close to this value too, but never actually touches it. So also put a parenthesis there. So our interval for increasing is parenthesis 0, 2 parenthesis. Okay. Now let's look at decreasing. So decreasing, so this is where the function goes down from left to right. So as you can imagine, looking at this, that would be the other part of the graph we didn't look at. So this one here, and you'll notice that from left to right, the graph is sloping down. And so we look at what values that covers on the domain. So we see that it starts here at -1, and then it goes over to 0 again. And just as a reminder, we're looking at the input values that are covered there. And then at -1, because even though there's the closed dot there, we're still going to put a parenthesis on that -1 because we don't know what happens to the left of that point, and that's where our interval starts. And then again at 0, we now see that it's kind of that point in the middle between where it increases and decreases. And in fact, as we look at this more later on this quarter, we'll find out that the graph is neither increasing nor decreasing there. So that's why we put a parenthesis. Okay, so our domain, or excuse me, our interval over which we're decreasing is parenthesis -1, 0 parenthesis. Great. So next thing we have to look at are just evaluating the function at some different values. So if we look at this notation here, remember that this letter here that represents the name of the function, and then the value inside of the function that represents your inputs. And so if we're asked to find f of -1, that means we need to find the output. We put an input of -1 into the function. So what we'll do is go over to our graph here. Here's our input of -1. Go up to the graph, and we see that the output there, the value corresponding to that on the vertical axis, is 3. So therefore, we know that f of -1 equals 3. Okay. Similarly for 0, we use that as our input. So we look at for an input of 0, what's the output? Well, right there it goes through the origin. So the output there would be 0. And then finally for f of 1, so we're using input of 1 now. See, that's here on the graph. We go up to the graph. Again, it looks like it's corresponding to an output of 3. So f of 1 is also 3. All right. So that's a little more basics of functions. Okay, so moving on, let's look at something called a piecewise function. And a piecewise function, it's called that, just as you might imagine, because it has different pieces. And so we notice over here on the left, where our function is, that there are 3 different pieces. I'm trying to highlight. So there are 3 different pieces over here for the function. Remember, the definition of a piecewise function is that each part of the domain, or different parts of the domain, correspond to different formulas or different ways of being graphed. So here we can see that there are 3 different ones. So we have the f of x equals x squared, the f of x equals 5, and the f of x equals x minus 1. Those are our 3 pieces, and each corresponds to a different part of the domain based on what these intervals here are telling us. Okay? So we're going to look at the first one. So f of x equals x squared, which you hopefully remember from pre-calc 1 is a parabola shape. And we're told that that is for the domain x is greater than or equal to 1. Okay, so that means we're looking at values starting here at 1 and going this way. And I need to make that go away. And so what I'm going to do is, I know that normally if I input 1 into the function x squared, I get an output of 1. But based on what I see here, I also see that there's a greater than or equal to thing, which means that I get a solid dot there. So I'll put a solid dot here at 1, 1. At least I'll try to. There we go. And then I know if I input 2, I get an output of 4. And if I were to input 3 there, I would get 9. And I can connect my dots so my shape kind of looks like this. And because it says x greater than or equal to 1, I have that arrow there because the graph just continues on. Okay, so that's the first piece. The second piece now is when f of x equals 5, and that's over the interval from -2 to 1. And you'll remember from pre-calc 1 that if we have a function f of x equals 5, that's a constant function. That's just a horizontal line. So this would be a horizontal line passing through the value 5 on the output axis, or your vertical axis, between the values -2 to 1. So we're going from here at -2 up to 1. And I notice in the inequality here for my domain, I have 2 less than signs, so they don't include equal to's, which tells me that that those points are not included in the domain of that part of the function. So that's why I have open dots. And as I said, the function f of x equals 5 is just a constant function. It's a horizontal line, so I'll just connect those two like that. Okay, and I apologize. I know that the drawing here is not the best. I'm doing my best with the technology and the stylus here. And the last part we have then is the x minus 1 here, and we're told that that's for values of x that are less than or equal to -2. Remember, x minus 1 is a linear function, so our graph here should look like a line. In order to figure out what the line looks like, I think I'll start by just inputting -2 into that function. So I know that if I do -2 and for x, I'll have -2 minus 1, which gives me -3. So if I input -2, I'm supposed to get an output of -3, which is here. And I also see that there's that equal to sign here, which means that that point is included. So I'll fill that dot in. And then it's a line. So maybe I'll just put in another points less than or equal to -2. So maybe -4 minus 1, give us -5. So I know when I input -4, I get an output of -5. And I'll connect those dots like this. Okay, and again, put an arrow because the graph continues on forever and ever. So I know it's a little sloppy over there on the right, but the red, purple, and then the green graphs, those together are a graph of our piecewise function. Okay. All right, moving on. This will be the last thing that I go over in this video, excuse me. So we're asked to find the domain of the function f of x equals the square root of 5 plus x over x squared minus 4. Now there's a couple of different things going on in this function and in this problem. So first of all, we're asked to find the domain, and as we talked about a couple of times already, the domain is the set of all inputs into the function, so the set of all possible things that can be put in for the input variable, which in this case is x. And we're looking for the set of what can be put into a function. Often it's helpful to think about what cannot be put into the function, or if there was any values we could put in here that might break some rules of math. So as an example of one of those, if I look at the numerator of this function, the top part, I see that there's a square root of 5 plus x. And I know that when I'm taking the square root of something, whatever is underneath the root has to be bigger than or equal to 0, right? Which means that this part, this 5 plus x here, that part right there needs to be bigger than or equal to 0. So I can actually set up an inequality here. 5 plus x greater than or equal to 0. I can solve that inequality by isolating the x. So if I subtract 5 from both sides, okay, and when I do that, I end up with x is greater than or equal to -5. And if we think about that, that makes sense, because if we plug in -5 for x up there, we get the square root of 0, which is an allowed thing. But if we put in a value less than -5, say like -6, we'd have the square root of 5 plus -6, so we get the square root of -1, which doesn't work. Okay, so we know that part of our domain has to do with this x being greater than or equal to -5. Now the next restriction we would look at, in this case, since this is a rational function, and we know that because it has a numerator and denominator, is the bottom here, the denominator. And we know that when we have a rational function, that the bottom there cannot equal 0, which means we probably want to figure out what does make that equal 0, because that's not allowed in the domain. And one way to do that is to take that bottom part, the x squared minus 4, and set it equal to 0, like that. And we can solve this by adding 4 to both sides. So we end up with x squared equals 4. Then we take the square root on both sides. Remember, when you take the square root, you always have two answers. So we get the plus or minus. So here we will have x equals plus or minus 2. And now those are the values that make the denominator equal to 0. But as we just talked about, the denominator is not be able to equal to 0. So these are actually values that cannot be in the domain. So we know that x cannot equal plus or minus 2. So now we have these two different pieces to use to write the domain. So we have that x has to be greater than or equal to -5, and it can't be equal to plus or minus 2. So using that, when I go to write the domain, do that over here. Okay. Well, based on the first thing I have from the inequality here, x greater than or equal to -5, I know that my domain is going to start at -5, and it says it's equal to, or it can be equal to -5, so I'll put a bracket there, comma. Now I start going values that are greater than -5, but over here I'm told that the function cannot, or x cannot be equal to -2. So for my domain, I'm going to go from -5, comma, up to -2. I'm going to put a parenthesis because I can't have -2 in the domain. I'm going to do a union. Now I can have values bigger than -2, so like -1.9, -1.8, those sorts of things. So I'm going to restart my interval here with another parenthesis, -2. And if you remember, that basically just breaks your domain there at -2, comma, up to the next value that we can't have, which is +2, parenthesis, okay, because that's not included, and I'm sorry, I'm going to have to go on a different line here. Do another u, start at 2 again, so again, we just kind of broke, and then we can have anything bigger than 2, so we'll go all the way up to infinity. Okay, so this answer should have been like bracket, -5, comma, -2, parenthesis, union, parenthesis, -2, comma, 2, parenthesis, union, parenthesis, 2, comma, infinity. And remember, with infinities, we always use parentheses. So this here, I'm going to box it in black. This would be our answer. Okay. So that's it for this video. Like I said, tomorrow I'll post a video with more stuff from this PowerPoint to help you with the section 1.1 and 1.2 homework. So in the meantime, you can start working on that. Thanks a lot for watching.